Thank you. Hi, everyone. So my first online convention, really excited. Just a second to set up everything. Okay, I'm good. So welcome. Thank you very much for having me. And today I'm going to talk about, unit testing in Java. So welcome to the good, the bad, and the stuff, a Java unit testing adventure. And we're going to talk about unit tests today. So first, let me introduce myself. My name is Itai. I'm a software developer at Velocity. I live in Tel Aviv, in Israel, with my wife Mor and my dog Leah, and the Lord of the house Snuggles, which we will hear about him later in the talk. Just a quick note, unfortunately, currently we are at war, and if the siren will go off, we have to go to the bomb shelter, so excuse me if this will happen, but let's get to it. So, Velocity. So the company I work for gives developers rapid cloud development within the IDE. We develop locally in your IDE to build and run and debug directly on your cloud and make changes and debug services that you are running in complex Kubernetes-based environment, well, straight from the IDE. It's great, and I love this company and having lots of fun in testing here. And today, we're going to talk about test. What we're not going to talk about is TDD. We're going to talk about unit tests, and we're not going to talk about integration tests. And all of the tests are important, but we're going to focus about unit. So we're going to talk firstly why use unit test, and then a definition of a good test and a bit of a good code. We'll talk about JUnit and Mockito. We'll explore fakes, mocks, stubs, and we'll talk about spies. Few unit testing principles. The 8 here is a mistake, my bad. And we talk about team testing paradigm shift, which is really important. So let's start. So first of all, why we even want to unit test? So when we say unit test, the term unit is defined in multiple ways. I read tons of definitions for unit, but I have one that I prefer the most, but of course it's up to you. So I took it from The Art of Unit Testing by Roy Oshov. It's a great book about unit testing, specifically for object-oriented environments, languages. So I suggest you read it. But a unit, he defines it as a unit of a work is the sum of actions that take place between the invocation of a public method in the system and a single noticeable end result by a test of the system. So an end result might be a return value of the public method. It can be a state in the system that changed, for example, a user that got logged out, a call to a third-party system, which the test has no control, like logging library or something like that. And also sometimes it might be a test effect of the function that we want to test, but we'll talk about it later on when we get to mocks. So why use unit test in the first place? So we have three main and really good reasons, in my opinion. First of all, the confidence in our code. If we had good tests, specifically unit tests, we'll be more confident making changes and deliver a good code. And it also will lead us to a better design. We will talk about it later on a bit in the principles of unit testing, but if it's hard for you to write a unit test, you probably should think about a better design for your system. If we listen carefully to our tests, which is can help us guide ourselves to a better and well-tested system. And of course, it's a great source of documentation. Usually it contains all the use cases, or it should contain all the use cases or the flows in the system, and it's for specific class under test. So usually when I get to a new code, the first thing I do is just go to the test because I see like the real use cases that we want to test in the system. And for that, I can study what exactly is going on, the edge cases and stuff like that. And another reason that we should unit test as well, or why, is because clean test code, well, it's not exactly why, but it's more a noticeable point that clean test code is important as clean production code. But it's not only about clean. So test code in general is important as production code because we spend a lot of time as engineers to understand the code that has been written in production. Right? You have a huge system in the company that you work for, and if you want to change it, you need to understand exactly what is going on. And if the production code is really readable and clean, it's really easy. And also, if the test code is clean and readable, it makes our life way easier because it's, again, lots of confidence. It's great for the documentation, but usually we tend to put less effort in test code. And my question is why, and we're going to talk about it in very soon. But before we get to the definition of a good test, I want a quick note about best practices. So in some cases we don't, or sometimes we can't follow best practices, but it doesn't mean that there is no value in doing them. For example, you have a legacy system that lacks modularity and testability, and you need to test a specific method. And ideally, you would refactor everything, and you isolate the dependencies and test the dependencies separately, and everything will be great and covered in tests, right? But well, the price of doing that refactor might be a price we can't pay. We don't have enough time. It will take us a month, and we probably just skip it in that case. So I probably avoid the refactor and find a way to test the method. But I will add the refactoring to the backlog because it's important. And also, if we consistently ignore best practices because we are unaware of them, it's only a matter of time that our code will start to rot, and we have points that we get to a point that it will be unmaintainable. It's really, really hard. But if we go against best practices, which is okay, we do so knowingly, and we understand the consequences, and we'll get back to fixing it in the future, which is great. Now let's get to the definition of a good test. So I think that three things define a good test. A good test should be complete. It should have logical coverage, not just line of code coverage. All the possible inputs, exception handling, and every possible scenario should be covered. It should be correct. For example, green usually it's when the code and the test run it's correct, and red otherwise when it fails. And clear, easy to understand, easy to read, and easy to change, which is really important. And usually when we talk about test, we hear the term test coverage. And I want to quote my friend in this case, coverage doesn't mean anything. If it's bad, it's zero. If it's more than zero, well, we don't know. It doesn't mean you shouldn't use test coverage, but just be aware of that point. So we talked about a good test, but we also need to talk a bit about good code, because again, a good test code is important as production code. So what about good code? So from the book Growing Object-Oriented Software Guided by Tests by Sif, Riemann, and Ned Price, they define a good code with 2 points. First, the separation of concerns. Every component should have only one concern and implement it well. When we have to change the behavior of the system or start refactoring it, we want to change as little code as possible without breaking everything. And the second point is higher levels of abstraction. This quote that the only way for humans to deal with complexity is to avoid it by working on higher level of abstractions. So when we can get more done if we combine components of useful functionality rather than manipulating variables and control flow. So that is why, for example, when we order food from a menu in terms of dishes, right, you don't get the full recipe and how exactly it's being made. And applying those two together, we drive our system in such a way that the code of our business domain is isolated from the dependencies and the technical components. It becomes much easier to test them separately, which is really, really important. So what is a good unit test? Specifically, a good unit test, first of all, it should be automated and repeatable. You can run it every time and really fast. Should be easy to implement. Anyone should be able to run it at a push of a button and how many times he wants. It should run quickly. It shouldn't take a lot of time. And it should always return the same result if you don't change anything in the code. It should be stable. And it shouldn't be dependent on other tests, because if one test is dependent on the other, it's the worst thing that can happen, because one of them starts, when one of them fails, the other one fails as well, or get flaky, and we can't control this behavior, and we don't want that. So what about what to test, which is really important, but I'm going to talk about like a few points, and I think it could be another different lecture about exactly what to test. So first of all, you need to test the behavior, not the methods. For example, you have a public API. So you want to test the public interfaces, or the interface of the classes or models or components, whatever you have. And you want to focus on testing how the code behaves externally rather than testing each individual method or function, right? You don't want to just follow the implementation, because when you change the implementation, you have to change the test, and you usually don't want it. you want to test different scenarios and edge cases. You want to test your function or class under extreme methods, not only in matter of stress, but invalid inputs, weird exceptions, and stuff like that. And of course, you want to test side effects and interactions. You want to test how a code modifies in internal states or interact with internal dependencies. And that is about that's about it, about what to test, and there's a lot of reading materials about it, and I can't get into it that much. But also when not to unit test. Now, this is really a hard one to demonstrate, but I won't get into it deeply. But I have a friend that told me he worked for a company that had 1 million unit tests. All of them passed, but the system didn't work. So it doesn't really help. There are lots of kinds of tests. You have integration, end-to-end, system, whatever. You have a lot of them. Each one of them, each one of those categories have a specific use, and I suggest you read about them and have the complete testing tools that you will be able to build an entire system and be very confident about your work. So in this talk, I'm going to use JUnit and Mockito. For those who don't know, JUnit is a widely used testing framework in Java, and Mockito is a popular mocking framework. There are a lot more than I'm going to show you today to Mockito and JUnit. So I suggest a deep dive because they are great, and you have also other libraries, but this is, I think, the most popular one, and I use them a lot. So they're great. So I created a simple shop project in order to demonstrate the test principles and to show you some code, because that is why we're here, right? So let me introduce you. Snuggies, the bunny supply store. We're going to have all the examples based on this shop, and let's dive into a basic implementation of the shop. So we have a class called shop. It has two dependencies, a cart service that is responsible for buying items and adding them to the cart. And we have a food service that is responsible for all the food items that we sell. We have carrots and hay and everything that a small fluff bunny eats. And we have two methods, and we'll add more when we keep going. We have the get food by ID, which is really simple, return a food by given ID, and add to cart, which given a cart item, we check the stock for availability, and if everything is available, we add it to the cart, and that is good. Now, before we get to the actual principles, I want to talk about fakes. So we have mock, we have a stub, and we have a spy. Spy is not actually fake, but usually we talk about them together. Those three concepts are the main essence of unit testing. So let's start with the stub. First, let's define a stub. A stub is a controllable replacement for an existing dependency in the system. By using a stub, you can test your code without dealing with the dependency directly. It's from the art of unit testing. I really like this definition, but let's see some coding example. So I created a class called shop tests that are using JUnit and Mockito, and we have the two dependencies, the cart service and the food service, and we use the mock annotation. Now, in Mockito, and I think in most of the testing libraries, everything is a mock. They don't really separate between a stub and a mock because it's more about the concept and not the actual implementation, but we annotate them as a mock. Now, the cool thing is that each test that we will run inside shop test will create a new instance of the class shop test, and we have those dependencies created and mocked again. So we don't have to worry about resetting a state or something like that, specifically in this class under test. And we have the inject annotation that will create a new instance of shop and will inject the cart service and food service specifically by type. Now let's get to the first test. I want to test the check stock availability method. Now, I like to use the pattern given when then. It's similar to the arrange act and assert pattern. I think it makes the test more readable. It gives the reader a clear partition of the unit test. So the given section is the setup of the test, the when is the actual execution, and then is usually the assertion part. Now, in this case, we want to again check the test the check stock availability method. It's sort of a happy case, and it should return true because it's a Boolean method. Now, the food service in this case is a stub. Okay, we create a new caret and we tell the food service that if the method get food by ID is being called with the ID of 1, you return the caret that we created. And then when we check the stock check stock availability, we use the caret ID with the quantity of 1, and we expect the result to be true. Now, stubbing, well, and again, mocking is all about the communication between the object. Okay, the stub here is not something that can fail the test. It's just something that we fake along the road of the function in order to get to the actual part that we want to test. Because if we can control what food service is returning, we can't check for stock availability inside the shop, right? Also, but if you have a dependency that is only a stub, and we'll see the difference between a mock and a stub in a second, so you can just add the annotation stub only. And the difference is, but if you use the stub only, it won't record any actions or any function calls that you make to the function. But it's also make it readable because you know it's a stub and not a mock. So if we look how the components are communicating, we see that the shop communicates with the food service because, well, it's a dependency and we stubbed it. But the assertion of the test is against the shop, not against the food service, which is really important in this case, okay? When we use a stub, we don't assert against it. It's just another step in the way. Now let's talk about mock. So again, as I said, in Mockito, everything is a mock, but it has a proper definition. So a mock object is a fake object in the system that decides whether the unit test has passed or failed. It does so by verifying whether the object on the test called the fake object is expected. There is usually no more than 1 mock per test. Now, this is usually no more than 1 mock per test, but I think that the main thing is that a mock can fail a test. When we assert against the mock, it determines if the test passed or failed, some sort of an assertion. So let's take example, take a look at the cart service for the mocking example. So I wanted to test the cart service, and the cart service has one dependency called the analytics service. Now, the analytics service is used for publishing events because we want to have observability for the system, that every time someone adds something to the cart, we want to get an event and have it in our system so we can analyze it later. For our company, observability is super important. So we want to make sure that the analytics service that publish the events every time the function is being called. So we'll create, we have the cart service test class, we have a mock of the analytics service, and we generate in the test, we generate a cart item, we call the cart service with the specific item, and then we want to verify that the analytics service was called exactly 1 time. The method publish item added event was called exactly 1 time in the analytics service. Now, why would we want to verify that some method was being called? Okay, so specifically, this is a side effect. The analytics service publishing event is a side effect of our function. Is really important to us. In our case, or in our system, we decided that no matter what, when you call this function, you have to have the side effect. So we want to test it in case someone accidentally or not accidentally will change it. Okay, if someone will remove this method or change it, we will no longer have the observability to this function that we want. So we want to avoid that and want the test to fail and let us know that this has happened. So again, about the communication, the cart service is communicating with the analytics service mock. And the difference between the stub and the mock, as you can see before, the test asserts against the mock, not against the cart service. So this is the main difference between a stub and a mock. So a mock can fail a test, a stub can't. And the communication between them is the main difference. And it's really important to understand this concept. Now, the final part, well, it's a spy. So a spy is an object that wraps around real implementation. It doesn't fake anything. And it gives us, allowing us the observation of the behavior of the actual code that we're using. So unlike a mock, well, again, it's an actual object that records functionality. But let's see a coding example. So again, with the cart service, we created the cart service using the spy annotation. it will create a real instance of cart service and wrap it with a spy. So the test looks really similar when we use the last test with the mocking, right? So we generate a cart item, and then we call the cart service with the add to cart, which again is a real instance of the method, and we want to verify that the add to cart method was called exactly once, and not only it was called with the specific item that we get. Because if something in the middle of the function changed the item, I don't know, the name or the ID or something weird, we want this test to fail. And well, the difference between a mock and a spy, it's pretty obvious. One is a fake and one is not. A spy wraps a real object and a mock just a fake object. So let's get to the testing principles. And also I used the Bing AI image creator a lot in this talk. I think it was the most fun I have making these slides. But I think that these principles will give you like basic guidelines that will help you write tests more effectively and more clearly, and make them more readable, and even lead you to a better system design. And I think none of them are really hard to follow. You just need to remember and understand those principles. Let's start. So as I mentioned at the beginning of the lecture, test code is important as production code. Okay, we need to spend, in my opinion, we need to spend time writing good tests at the same time as we write good production code. And I have like a few tips to make your test code clean as production code. So the first one is well known as singular responsibility. Okay, the same way a function has one responsibility or a class has one responsibility, the same goes for testing. I abuse the flow here a bit just to make it shorter, but in this case, in this test, we test two different functionalities. Okay, we have the calculate order total and the process payment functions of the shop, and we assert both of them. We want to check that the order total was 50 with a delta of 0.01, and we want that the payment processed was true in the process. Okay, so in this case, it's obvious that we need to split this test into two functions, because if this test fail in this current state, we need to check the error and see the code to understand exactly what failed. The order total was wrong, the payment wasn't processed, it's not indicating anything, okay? So one test, one purpose, one responsibility. Now, at least for me, when I started writing unit tests, I had like really, really big set of functions, and usually it's not a good thing. First of all, it's not readable. But if you have a really a long setup, probably you can use a higher level of abstraction in order to deal with it. That also higher level of abstraction, like the concept with functions, with dependencies, I think is the answer for almost anything in unit tests. But in this case, we have a test that we initialize a shop storage, and we create DB tables, and we fill the food table and other table and stuff like that. Lots of stuff that are probably important, but are not really the focus of the test. So we can just extract them into initialize database function and just call it. If someone needs the implementation, he can deep dive into the function, but it makes the test more readable, shorter, cleaner. And the next point is reuse. The same way we reuse code in production, we reuse the code in tests. If you go under a code review and you have the same function written 5 times, someone will tell you, hey, you need to reuse the same function. So my two favorite functions to reuse is usually assertion functions. If I have a complex object that I want to assert, I can use equals in hash code, and it will be easy. But sometimes I want to assert only specific fields, so I will extract it to a function. In this case, assert equal foods, and it assert every single field that I want, and it can have a message, and it's great. And also, when I'm generating items for testing, I don't want to each test to have food equals new food and stuff like that, like a really huge constructor. It's a waste of time and space inside the test. But also, if we have, let's say, 20 tests that have this initialization of the food object, and we want to add an additional value, we'll have to go to each and every one of them and change them, instead of just going into one function and change its behavior. And if you don't really like those generators methods, you can use a builder. And I think it's another really clean and easy way to go. You can create a class level builder that has all the values of the class, in this case food. And when you test when you test some method, you can just change one field, and that field will be the main focus of the test. In this case, we want to test the legal description, so we will go to food builder with specific description, and we'll give it an illegal description. It's really clear in this test what the main focus is about, not only by name, but also by code, the description, the legal description. That's what we want to test. It's way cleaner, right? So let's move to the next one. So clear names and magic numbers. So I think that one of the first rules of clean code, the first chapter of the book, is clear names for classes, for functions, for variables, and the same goes for tests. If you have a really unclear and long name, that will be unreadable and it will indicate anything. So my favorite convention, as we've seen so far, is the first part of the test is the name of the function that is under test. The second part of it, it's an input or scenario or state, something that indicates what's going on. And the last part is what it should return. In this case, calculate discount with high total should apply 20% discount, for example. But it's all about convention, right? Because if the entire team agrees on one convention, it's different than that. And this one, that is fine as long as it's clear and everyone is on board, and you keep doing the same and you stick to that convention. And magic numbers, well, take a look at these examples. Which one is more readable? You have the first test that indicates that assert equals 0.20 with discount and 0.01 delta. I mean, what are these numbers? Do they have any meaning? And in this case, they might have or might not, but I suggest to extract them into variables. So in this case, we use the expected discount percentage and delta. And then you can read the actual numbers. But I think that the way I look at it, that if a number has no meaning in the test, you can use the variable name or constant name, any number. And you can put 5 or 10 or whatever you want, because it doesn't really matter to the test. But if it doesn't have meaning, use a meaningful name. For example, illegal size or long time ago and stuff like that. And then the reader will be able to know why is it important. Okay, so avoid multiple assertions. I'm sure that you've heard that only every test should have only one assert. Usually it's really hard to follow. But if you have too many assertions, well, you might be testing multiple things, and you need to consider splitting your test into multiple tests. And it's really hard to understand what is the main focus of the test, right? If you have multiple assertions, it's not clear. So you can either extract it into a function that asserts everything, in case if it's a complex object like food that we've seen before. But another suggestion is to use the happy case. You have one test that is the happy case test, and you assert all the difference between the object that you expected and actually got in the response. And in all the other tests, test the edge cases. That's the meanings, the other things, that one field that is different, or the illegal description, for example. Don't test the whole thing again. Now, in Mockito, we can use any, which is kind of a magical argument matcher that will match to, well, anything. So we have this test, and I want to test the add to cart again in the happy case. And we said that the food service will return a carrot to whatever ID we give it. Any integer will return the carrot. And then when we verify that cart service was being called, the add to cart function was called, we don't care the input, we can just say any. So the thing is that this might mask many issues, right? Because if we change the ID inside the get food by ID function, for example, and we return a different carrot, well, or we return the same carrot, we have a bad behavior, right? The code is broken, but the test still passes, which is really bad. And I will use actually the actual ID or the actual item that I expect to get, because that is the meaning of the test. We want to verify that the function was being called with the right input. But if you really have to use them, you have any int and any string, which is a bit better. And I think that the only place that I allow myself to use any is when I'm handling exceptions, because I don't really care about the input, I care about the exception handling. So any can hide issues, but also mocking. And mocking can be pretty dangerous. Okay, you need to use them wisely, because mocking is about setting expectations, and if the expectations from the test are wrong, so probably the test will fail, or the test is wrong, and it don't give us the confidence that we want in our system. So when to mock and when not. So I think that first of all, when don't mock, start with the don't mock data structures. Now, when I talk about data structures, I'm not talking about hash table or linked list. I think that Bob Martin explained it well. So the difference between a data structure and an object is that a data structure have visible data and no behavior. In our case, the food object. Okay, we don't want to mock it. We can just create a real one. And don't test well-tested libraries. For example, object mapper of Jackson. You don't want to test it. It's already well-tested. If you start to test it inside your test, you have bajillion more tests, and it misses the point. And don't mock static functions unless you really, really have to. It uses when you use a static mock, it relies heavily on reflection. It really slows you down, and it's really, really hard to maintain those tests. Believe me, I had a lot of time dealing with the static test, and I refactored everything. So don't do that. And when to mock? When you have an interface, want to control over its behavior, want it to be isolated when it's under test. Usually, an interface, when talking about a dependency of the class, we test it separately, and we want to test its behavior within the class. When you have an IO dependency, for example, user input or something like that, you can mock it. If the real code slows down the test like a lot because it's really, really heavy, you can mock it. And if the dependency is already well tested, which is similar to the interface, well, you don't have to test it again. Just test the communication between the components. Let's get to the next one. We want to fail informatively, which is really important. So when a test fails, we want to quickly diagnose the issue. We don't want to start looking at the test code and the production code to figure out what went wrong. So in JUnit, you can add to the assertions, you can add a message. Now, usually the test name, if it's clear enough, it indicates what exactly went wrong if you test only one small thing. But you can add a message to the assertion. For example, here, food should be null. So when the test fails, you have the message food should be null, and you know that it returned null, and the get food by ID returned null, and you need to check the method what went wrong. But also you can do that the same with mocking, not only with the assertions. In this case, if the cart service add to cart was not invoked, so we add a description, which is a failing message to the test that the cart service add to cart was not invoked. We expect it to be invoked. It makes it really clear. So a good message is a message that helps you avoid opening the code to figure out what went wrong. So it's really important. And the final point is some sort of a bonus point. If you have a hard time to write a test, you probably should consider redesigning, because I've talked about it a bit in the beginning. We need to listen to our tests. If it's hard for us to write a unit test, we have a good reason that this happened, right? And unless it's like the first time you ever write test, or you didn't have much experience with that, it takes time. But when you get when you have enough experience with writing unit tests and it's still hard for you to write it, you probably need to do some redesign. So your class may not have, probably your class might not have too many dependencies. Like, think about if we took the shop class and the food service and the cart service and implement everything in one single class. It makes no sense, right? You take some logic from the class and you extract it to dependency, and you test that dependency really well, and you inject it into the class, and then you mock it. You don't have to test it again. It will make your classes smaller. You will have to write less tests per class. You don't have to write like multiple tests to test the connection between those services. And so you should consider refactoring. I spent a lot of time doing that, and every time you do that, first of all, you feel relieved because you see less code, and you also use the higher level of abstraction concept, which again, I think it's one of the main principles in unit tests. If things get hard, just abstract as much as possible. So I don't have any examples for this case specifically because it involves a lot of code and can be a talk for itself. But I think that those two books that I mentioned in the beginning of the lecture, The Art of Unit Testing and Applying Object-Oriented Software Guided by Test, I read them both and they're amazing. And I think they changed a lot of how I think and how I approach to test and system design. And there's also a great lecture from J.B. Rainsberger, Integrated Tests Are a Scam. It covers a lot of concept about test and system design. And go watch it. I think I looked at the test and things really differently after I watched this talk. And the final thing is that, well, what about our teammates? So the last place I worked for, when we started, lots of engineers were like, nah, testing. I don't want to touch it or it's useless. And I heard lots of explanations why we shouldn't test or not focus a lot about this. It takes too much time. But slowly we led a team testing paradigm shift. So we started with lectures and talks about tests, why they're so important and how to do it. And I think one of the main things that we did that was really helpful was the hands-on workshops. So ChatGPT is great for the things. I created a company and a story of a store called Silly Socks that sells socks, and created well, again with ChatGPT a lot of functions and boilerplates of the code, and most of the code was implemented. And then we settled together. It was, I think, about 3 hours, and we wrote lots of tests, and we changed the behavior of the system during the workshop, and they had to refactor the test and abstract parts of the code. And I think that once you get a hands-on experience with that, with writing tests, I think it's great, and I think it really helped the entire team to be more involved and understands why tests are so good for us. And also, you need to have code review standards. Okay, I'm not talking about running a test in the CI, which is really important, but usually when I code review, I look for tests. They might be in a different PR, which is pull request, which is great, but I look for tests because they're important to me and they're important to the system, and we need to validate it. The quality of the test is the same as the quality of the production code. And of course, don't stop talking about it. I spent the last 2 years talking about tests nonstop, and I think that it made a difference. So let's get to the conclusions. So we talked about what is a good unit test. A good unit test is clear, correct, and complete. We talked about differences between stub and a mock, that the mock can fail a test and the stub can't. We talked about spies after a real object. We talked about the principles of unit testing, the single responsibility, a clean code, the naming, avoiding magic numbers, the generating method, the builder. And we talked about when to mock and when not to mock, which is super important. And of course, fail informatively. Now, the main thing that I hope that you will take from this talk is that you should listen to your tests, and it will guide you to a better system design, and it will increase your confidence in your code and your system in your work. And I just love it. And of course, pass it on to your teammates. Thank you very much. And if you have any questions, this is the time.
There are a couple of questions in the chat.
Okay, let me see. Okay, so what scenario should we use spy over mock? I can't. I don't have like an example at the top of my head, but there's some cases that we have a real object that we want to test, and we don't want to mock. Well, I need to think about it a bit. Give me a second. Well, it depends if it's a real instance or not. I prefer to test real instances. Okay, because when we mock it, we wrap it with a fake object, or we let Mockito handle the object. And sometimes you just want a real instance and check its actual behavior. But I'm sorry, I don't have a good explanation or an example from the top of my head. But I need to think about it. I find one. Okay. Okay, so can you elaborate more about why code coverage does not matter as long as it's more than zero? Yes, because let's assume that we have lots of unit tests and the code coverage is 100%. I again, I can't like show right now an example, but if you have a function that, okay, let's talk about line coverage, for example. You have we have tests that covers each line of the code, but it doesn't mean that it covers any possible input to scenario. Okay, let's say you have a function that doesn't handle null object, and you have tests that for calculate, let's say the function add or something like that, and assuming that the numbers are wrapped in object boxed integer. So we checked all the possible scenarios. Yeah, you can add 1 and 5 and 0 and everything works fine. But if I pass null and you get a null pointer exception, and you don't test that, the testing coverage wouldn't tell you that you missed that point. So you can have 100% coverage, but you don't actually cover 100% of the use cases in your code. Do you use mutation testing? I'm not sure I know what mutation testing is. Derek, you want to tell me? Maybe it's like a different definition. I have no idea what mutation testing is. But I had a short slide. I removed it a few days ago about the parameterized test. I'm not sure it's the case. Well, okay, sorry, I can't follow it. It's too fast. About the mutation testing, sorry, I'm not sure what you're talking about. Considering that mocking a static method is needed for a test, does it imply that refactoring is needed? Well, it depends on it really depends on the function. Usually for me, I think that it does imply refactoring. Well, it really depends what the static method do, because if it has a big impact on the behavior of the function, it probably should be a dependency. I had in the last company I worked for, we had a singleton class, a static class called resources provided, that provided all the resources to the code that we needed. And we mocked it hardly using static mock. And instead of that, I abstracted everything, and instead of initializing everything in that static class, I added another layer between them. So I can test my classes as if they have regular dependencies, and I left the static function alone. And I could test it separately, but it was a simple singleton that created objects, so I didn't have to. So usually, in my opinion, and I need again to see a specific example, but I think it implies that you need to refactor. Wait a second. Wait, Derek, when the app code is mutated a little, expectation and the test shouldn't fail. Change the issue. Well, give me 1 second. Let me think about it. Well, I think it's useful because you change the behavior of the test. For me, if I have a test, and okay, I have a test and I believe that my tests cover everything in the system. So if you make one small change specifically in the behavior of or the logic of the function, like changing a function from if something to if not something, I expect at least one test to fail. So I would do that. I would test it. I will see how it goes, but I never tried doing that in an actual test. But I think they're useful. Uh, okay. Anything else? We have 30 seconds. Okay, so thank you very much for having me. I had a really good time, and I hope to see you again in the near future.